Okay, so welcome to lesson 5, sine law part 2. This one's all about what we call the ambiguous case. All right, so there's one triangle that you have to be on the lookout whenever you're using sine law, cosine law, any of that stuff. And there's really only one you have to worry about. The only one you have to check. Now you can read textbooks and all this stuff that talk about all these different ways of checking and doing this and doing that. But all you have to be is on the lookout for this. So yesterday's examples, we talked about, all the different cases. And the ones you can solve with sine so far were angle, side, angle, and angle, angle, side. Well, the one we're talking about today is angle, side, side, which has that fun name, right? Angle, side, side. So it's easy to remember, right? Because it's got the great name. All right, now in this case, and I'll try to show you how as best I can. Your textbook covers it, but it doesn't. It does it. I just don't know if it goes deep into it enough. So I might talk for a long time. I'm sorry. It's an important one and you got to know about it. All right. So in this scenario, we can get two triangles, one triangle, or no triangles are possible with the given information. Now, why is that? Well, let me just kind of draw a rough sketch here, and then I'm going to use a web app here. And if you see this link below, you can type it in yourself if you want to stop at some point and try it out. Also put a link on our EDSB website there. You don't have to, but I'm going to show you kind of how this works. So let's just say we have a triangle, right, like this. And all we know for sure is an angle here, right? So I don't even know this side. Don't know. I know this angle here, so I'm just going to write A for angle. I know this side right here, and I know this side here. Now, I don't know this angle here. So maybe this side goes to here, maybe it goes down to here, maybe it goes this way. It could go anywhere. I don't know that angle. So the problem is this line here might be too long. It might be too short, like one of these guys. It might not reach because I don't know the length of this either. So these might not even touch it, or maybe it's too long. Maybe it doesn't make a triangle because I don't know. There's too many unknowns here. So there's a whole bunch of different scenarios you can get. So again, what you're looking for is were you given one angle with two sides, and the angle is not between the two sides. Now, if you're wondering, well, what's the other scenario? You can get a side angle side triangle, but the good news is if you try to solve that with sine law, it won't work anyways. You'd have to use cosine law. So this is the only one you have to look out for. So just basically, if you are ever given a question with only one angle and you can solve it with sine law, this is the one. That's what this whole lesson is about. So you just have to be cognizant and paying attention for questions where you're only given one angle. Because if you're given one angle and you can't use sine law, you're going to have to use cosine law anyways, so it doesn't matter. All right, so this is the whole lesson is about this. So I'm going to go to this web link here and show you a graphical version that makes it a lot more clear. Okay, so I'm on GeoGebra, which is a site you can make all kinds of geometry diagrams and things with and play around. Students can work with it too, but the main thing here is this is our angle, side, angle, triangle. So you see where my mouse is here. There's our angle that we're given. It's 30 degrees. Now we don't know this length at all. See this line here? No clue how long this is, right? We don't know this. So we have an angle. We have side B, which is 9 units. And then we don't know angle C, but we do know side A. So this is angle, side, side. Now see how it's swinging back and forth? It's swinging there to show us we don't know angle C. So this line could be going here, could be going there, could be going anywhere. So in this case, see this triangle that's drawn? This is impossible. This triangle, that side A right here that's swinging back and forth is too short. It doesn't reach all the way down to here no matter where you put it. So this would be one of those scenarios where there's no triangle possible. And I'll show you through examples what happens when that happens. All right, so I'm going to come over here and use the slider. I'm just going to make that line a little longer so I can make it so it's starting to reach, it's getting there, it's almost at the bottom. If I can just get it just perfect enough, boom. All right, so one of the scenarios is it reaches down just enough and touches, and it actually makes a 90-degree triangle. So a right angle triangle. So that's our next possible scenario. So far, no possible triangle, or we could have a right angle triangle. And we know how to solve a right angle triangle. We could use sine law, we could use SOHCAHTOA, no problem. So there's nothing weird there. Now, the next scenario is this. Okay, so now what if I take that length A, and what if I make it even longer? So let's make it longer. Now see what's happening here? As it gets longer, I have two triangles that are possible. Now, see how they labeled it B1 down here and B2? Those would be the two possible corners where B could be. So if A is over here at B2, our triangle could be this entire big triangle. Here's corner A, here's corner C, here's corner B, right? Big triangle. But if you take A and swing it the other way, because we don't know what angle C is yet, right? So angle C could be this really big angle here, where I'm trying to kind of draw with my mouse. Or angle C could just be this little angle here if we swing A like it's swinging all the way over to here. And we could have the smaller triangle. That's the triangle that's just in all blue up here, right here. All right, so there's that scenario, right? And then A can get bigger and bigger and bigger and bigger and bigger and bigger, and then it gets way too big, and look, we don't have any triangle because A is way too long, it doesn't reach. So this might be a little overwhelming. You can play with this if you want or not, right? But we could have no triangle. We could have a 90-degree triangle, like oops, there. Or, like I said, A could be swinging back and forth, and we could actually have two possible triangles here. One when A is going to be 1, and one when A is going to be 2. So it feels like a lot, but when I break it down, if you kind of pay attention, I'm going to go through each scenario. You really only have to be looking out for one thing, okay? And I'll explain that as I go. So I just want to walk you through what would happen in each scenario and what would you do, okay? And then you'll realize, hopefully you'll realize there's just one thing you need to make a note of, one thing you really need to keep in mind, and that's it when you're solving trig to watch out for the ambiguous case. Okay, I'm back on our note here, and I'm going to look at basically the 4 scenarios we really need to worry about. Okay, now the first scenario was when A was too short. So that's what I'm going to write here. So that's our first triangle right here. There we go. And the problem with it is side A is too short. It doesn't reach. So if you look at that, A is just the length we're given, because remember, these are the 3 things we're given. Let me highlight them. We're given angle A, we're given side B, we're given angle A. So again, this is an angle side triangle. So we're given those, and A just doesn't reach all the way down. There's no way we can make a triangle, right? So in this case, you will have 0 solutions. Now, I kind of got this note broken down. This is my old grade 11 note. It needs to be fixed up a little bit. But, okay, let's look down below. How to tell which case you have. Start by assuming okay, blah, 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 blah. I'll explain it here. Now, what do I do? Let's talk about that. How do I know, right? And what do I do? So what ends up happening is I start solving for angle B, which is what would be here, right? This is where angle B would be, right? But it's not there because it doesn't reach. So what you normally do is you just start solving like normal. You wouldn't even, suspect anything's weird. You'd solve for angle B. And you'd set up your sine law, sine B over side B equals sine A over side A, and you'd start solving. And what you end up doing is after you use your sine law, you get an error. So in your calculator, you get an error, and that means there's no triangle. And we're going to do an example of one of those below in a minute, okay? So therefore, there's no possible triangle. All right, now the next scenario, let's look at scenario 2 here. A in this case, and there's nothing weird you have to look for again. So we got angle A we're given, side B, and side A. All right, now in this case, A reaches down just long enough to just come down and touch this at a 90-degree angle. So there's nothing really special here. All that you end up doing is when you solve for B, you get a right angle. So this is a right angle triangle. So there's nothing really special here. Angle B equals 90 degrees. Okay, so there's only one solution here. So again, you start solving for B. And in all these scenarios, I'm just using B, but in all these angle side triangles, you have no option. You have to start solving for this angle. So you won't even have a choice. That's the first thing you have to solve for. There's no way around it. So don't get panicking on, well, how do I know what to solve for first? In all the angle side triangles, the first thing you have to solve for is the angle across from here. Because all we have A, right, in both of these. And we have side B, so the first thing we have to solve for, because we have nothing to do with C, is the angle across from it. So you can't mess that part up. You have to solve them the same no matter what. Okay, so you start solving for side B, and long story short, you get angle B equals 90 degrees. And that's just a right angle triangle. So you just solve it like normal. Nothing special. You just solve it. You can use SOHCAHTOA. You can just keep using your sine law to solve for the rest, and it all works out. The end. All right, now these next two are the two weirdos. These are the two when we were looking at it where the line was swinging back and forth. So this line here, side A, it could be here or it could be here, okay? So it could be in one of two places. So Now in the first case, you start solving for A, and you find out, let me just erase this here because we'll talk about this. We'll just leave it. I'll erase it. There we go. All right, you start solving for side A, and there's only one possible triangle. Why? Because if you swing A, see how this showing this swooping here. If you swing A the other way, it's too long. Like let's say it won't actually reach to create a second triangle. So again, don't panic. I'll show you how do I know that happens. You just start solving the same way, okay? And I'll show you in the examples how to check that, okay? So side A is too long for a second triangle. For two triangles. Okay, so there's only one solution here. And I'm going to put these two together, describe both these scenarios together down here. 3 and 4, we're just going to put them into one big scenario, okay? All right, now the other and the final scenario is where you can get two triangles, right? A goes here, or when we swing it over, it could go here. So there are two possible triangles. So let me just draw them out and make it clear what those two triangles are. Okay, one of the triangles is the full one, like this. Oops, man, that's sloppy. Let's try that again, hey? Oops, well, it's back. Like I said, these are not perfect. There are one-take videos, guys, sorry. All right, so here's the big triangle. Okay, so I'll fill it in. There it is, one big triangle, right? So that's your first scenario. Your second scenario is if we swing A over here, we got this little skinny triangle instead. Okay, so there's two possible triangles, either this little one or the full big one. All right, so in this scenario, side A is the right size for two triangles. And there's two solutions. So there's a reason why we call all of this the ambiguous case. Anytime you get an angle side triangle, angle side, we call it the ambiguous case, because ambiguous meaning it could be different scenario, it could be different things, right? Ambiguous. Is it this? Is it that? There's more than one case. So there's 4 scenarios we've looked at here. Now, for that last one, let me just move it up here a bit, sorry. What do we do? How are we going to solve? And I'll show you in the examples. This is basically it. If you start solving them, all of them the same. The first one just doesn't work, so no problem. The second one, you get 9 degrees, no problem. The third and fourth one, don't worry about differentiating or freaking out. Here's what you do, though. Anytime I see an angle side triangle, anytime, this is the only thing I'm ever on the lookout for, okay? Here's the steps I go through. Number 1, just like the other ones, I do the same thing. I solve for angle B. Okay, now I'm going to call it B1 in this case, just so I can differentiate because there's going to be 2 B's, right? Here I'm going to call this B1 and B2 up in my diagram, okay? Because there could be 2 angle B's depending on where it is. So right now you don't know that there's going to be 2, you just start solving for B, right? Now what you do is anytime, if you don't get an error and you don't get 90 degrees, all you do is anytime you have an angle side, you assume that there's going to be 2. So assume, just assume, now maybe there is, maybe there isn't, but assume there are 2 triangles. Okay, so what we do is if this is the B in the first one, okay, we are going to find the B in the second triangle. That would be like right here. Okay, so how do we do that? I'll cut to the chase. I'll draw you a diagram in the examples to show you how it works. But what we're going to do is find the other B. Find angle B2. And I'll show you why it is this later, but angle B2, oh, I can show you here in a second, is just 180 minus angle B1. Now why is that? Let me just draw a triangle here. Let's just say here's B1 here, right? Well, this length and this is A and this is A, right? Here's your A. This is this triangle I'm basically drawing right here. Those are both A's. So this is an isosceles triangle, right? 2 angles are the same, so the angles across them are the same. So this would also be the same as this. So let's just say this is 50. Well, then this would have to be 50. Now the other angle is on the outside here. So how do I find that? Well, that's called a supplementary angle. It's 180 minus 50. So the outside, that angle there would be 130 degrees. So it's the same every time. So this is it. I'm going to highlight this because this is just the key. All I do anytime I'm solving and I get an angle side triangle and I don't get an error and I don't get 90 degrees is I just find the other angle by subtracting from 180. That's it. Okay, so now what I have to do is I have to solve 2 separate triangles though. That's the catch. So now you find the angle C's. So there could be a C, right? There could be a C up here. That's the whole thing or just the little c. So find angle C1 and angle C2. And we'll go through that when we do the examples. It's just 180 minus the 2 angles you have. And check, so step 4, check that both triangles add up to 180. Okay? So if both triangles' angles don't add to 180, well, that means we don't have two triangles. If they do, we have two triangles, okay? So we're going to check that out. I'm going to walk through all the scenarios so you can see what happens and what we would do in each scenario, okay? Okay, so we start solving our triangles and we're given two sides and an angle, right? We have two angle side-side triangles. Every one of these is an angle side-side triangle. Now, how do we know, what scenario we got? I don't freak out about it. Now, here's all I do is I just start solving like normal. Okay, all I got to be careful though, because I have an angle side-side, I just got to pay attention and just be careful and see if I have two triangles or not. So right off the bat, we got a triangle here. I'm just going to draw it real quick. I'm going to pause and draw it. All right, I didn't pause that long. I just drew a little bit of it. All right, so let's say we have angle A. Now, angle A in this case is an obtuse angle. That's where we have to be careful. This is why I'm saying this is really obvious. So there's that 110 degrees right there, right? There's angle A. So this triangle would open like this. Now this line could reach all the way down to here, right? And we could have a triangle, but I'm going to erase that for now. So what do we know so far? Well, we know there's angle A. I'm just going to put angle B down here. We have no idea what it is. I'm going to put angle C up here. We have no idea what that is. Now we know side B, which is right here, is 23. Side A is only 15. So let's just think about it logically looking at this picture. How in the world could this line be 15 but be, so much longer that it reaches all the way down to here? How can this be 15 but this is 23? So just looking at it, this doesn't make sense, right? There's no way that this is going to reach all the way to there. But let's say we didn't catch on to that yet, okay? Let's just say we're oblivious, we have no idea, we're just solving like normal, right? All right, well, let me just draw that line A in. Now, it's going to be too short in this scenario, so it would look something more like this. A equals 15 units, right? Because it's just not long enough. Look at B. There's no way it's longer than, right? It's shorter than that. It can't go all the way down there. But let's say we didn't notice yet. Let's say you drew the whole triangle and you just start solving, right? Okay, so here's what happens. We have no choice. So again, let's just say you drew this all the way in. Sorry, I'm just going to all the way to there. The first thing you have to solve for is B. You have no choice. You can't solve for C. You can't solve for side C, right? We can't solve for those. All we can solve for right now is angle B. So let's start with that. We're going to use our sine law. So I'm going to go sine B over the side across from it is equal to sine of angle A over the side across from it. All right, so let's sub in what we know. We have no idea what B is. We do know the side is 23. Okay, sine of A is sine of 110 and divided by the side across from it, which is 15. All right, so to isolate B, we're going to have to multiply both sides by 23, and then we're going to have to take the sine inverse to get rid of that sine there. So let me just write that out in one step here. So B would equal the sine inverse of all of this. All right, 23 times sine of 110 divided by 15. Now, I'm just going to save us time by, if you punch this in your calculator and you want to try it out, you should get an error. Okay, it's not going to work. You get an error because your calculator is saying it's impossible. There is no such angle. So in other words, I'm just going to erase all this junk. There is no angle B that can reach. This A here is just not long enough to reach all the way down to B. Okay, so you get an error. So again, it's nothing you had to memorize. You're doing an angle side-side, you get an error. Okay, this triangle is not possible. Let's do one more. We should get an error in this next one. It's a little less obvious, but it's the same idea. So let's just draw our triangle here. I'm just going to draw, here's one line, here's the other line. All right, so I'm just going to start with that. Now again, you might just draw a regular triangle right off the bat. I'm just going to kind of draw what's going on here. So let's say here's A, here's B, and C again, right? Same problem, same scenario. Okay, so we have side B again, which is 122. We have side A. Now A is 70, so maybe it does reach. I don't know. Maybe, it's a little bit longer. Maybe it reaches to B, maybe it doesn't, right? It's not going to, but, right, maybe we don't know at this point yet, maybe, right? So I'm just going to draw it to here, right? There's A equals 70. All right, so maybe it reaches down, right? Now, there's no choice. Here's C, here's side C. You have no choice. You can't solve for C or angle C or side C. It's impossible because you have to have one of the pieces of information. So you can try to solve for B down here. All right, so let's set it up again. Same thing. So sine B over side B equals sine of A over side A. Now, obviously, every question is not going to use ABC. They might use different letters, but it's the same patterning, right? All right, so sine of B, no idea what angle B is, divided by 122 equals sine of A. Oops, I forgot to write that in my diagram. There's angle A right there at 42 degrees. All right, sine of 42 divided by side A, which is 70. And long story short, again, we're going to multiply both sides by 122. Then to get rid of sine, we have to take the sine inverse. And once you do all that, you're going to get B equals the sine inverse of the entire fraction, 122 times sine of 42 divided by 70. Now, if I was punching this in my calculator, here's what I do. I'd start with the sine of 42 there. That's the first thing I'd do. Then I'd multiply it by the 122, right? Then I'd divide it by 70. And then I'd have to hit sine inverse of that number. So you might have to hit sine inverse and then answer in your calculator. If you hit the answer button, it recalls the previous answer. All right, instead of trying to type in a bunch of decimals. All right, so again, if you do that, what you end up getting is an error again. All right, so both of these, that A, I'm just going to erase it. It was not long enough to reach, right? It couldn't reach. So there's our two error scenarios. So in both of these situations, what you would just say is, therefore, there's no solution. Okay, you're not expected to solve the triangle. It's impossible. So we didn't have to memorize anything there. We just came across an error. Now, it's always a good idea to double check your numbers, look at everything. Did you put everything in the right space? Don't just assume. I've had people write a test and write no solution for everything, and they're like, I got an error for everything. And you're like, okay, obviously they weren't all errors. Did you have your calculator on radians by accident? Did you draw the diagram wrong? Did you put all the numbers in the wrong spot in your formula? So double check it. But there's our first scenario. All right, let's move on to the next one. Okay, so here we go with the next scenario. Scenario 2, when you get a right angle triangle. Now, again, when you start, for all of these, you're just going to start drawing. This is what I do. All of them, I just start drawing like this. And I go A, B, C, and I start filling everything in. What's going to happen here, though, is when you solve for B, you're going to get 90 degrees. So obviously, this is a super inaccurate diagram, but that's okay. You can still solve for the rest of the stuff like normal. No big deal. The main thing is we can find the numbers, right? But so since you can already draw it that way, I'm going to draw it more accurately of exactly what should be happening. All right, so here we got this here and here. And what's going to end up happening is, we wouldn't know this to start. Here's A. Here's corner or vertex A. Here's B. And here's C up here. All right, so let's just say we don't know how long A is yet. Could be long enough. It might not, right? So I'm just going to write A equals 5, B equals 10. And we know angle A is 30 degrees. Now, I have no choice, right? Let's just assume this goes all the way down here, right? I have to solve for angle B first. No choice anyways. Whether I know it's right angle or not, I don't know, other than obviously I've set this question up this way, but we're doing it normally. We have no clue. All right, so we have no choice. We start solving for B again. So I'm going to go sine of B, because I'm looking for angle B, divided by the side across from it, equals sine of A. So sine of 30 degrees divided by the side across from it. Okay, so let's multiply both sides by 10, and then we're going to take the sine inverse to get rid of that sign. So B is going to equal the sine inverse of the entire expression, 10 times sine of 30, divided by 5. Now you could just take that 10 and divide by 5 and make it a 2 if you prefer, and go sine of 30 degrees, times it by 2, and then do the sine inverse of that number, okay? And we are going to get out B is exactly 90 degrees. All right, so right there, if the light bulb should go off in your head and say, oh, it's a right angle triangle, right? That's 90 right there. Okay, so this is nothing special. You can solve this using Pythagorean theorem. You can solve it using the sine law, whatever you prefer. Okay, you can solve it using both, so you pick. Now, let's find angle C up here. Well, that's going to be easy. Once you have two angles, you can always find the third by subtracting from 180. So 180 minus 90 minus 30, and what do we end up getting is 60 degrees. All right. Now, how are we going to solve for side C down here? Right? That's up to you, like I just said. If you want to use Pythagorean theorem, you can use that. If you want to use sine law, go for it. I'm going to use Pythagorean theorem. Why not? Because we haven't used that much. Pythagorean theorem. Okay. So c squared equals a squared plus b squared, although the c, a, and b are in the wrong spot. So I'm just going to set it up as 10 squared equals 5 squared plus c squared. There we go. So 100 minus 25, take the square root of that, is equal to side c. So c equals the square root of 75. right? Which is, we're just going to say it's approximately 8.7. That's how many units it is. There you go. Now, again, you could also use sine law to solve for that side. You don't need to use Pythagorean theorem, but since it's a right angle triangle, I can. So there you go, easy to solve. There's nothing special there. There's no tricks. You just start solving it like normal and you get a 90-degree angle. That's pretty rare, but it does come up. All right, now we got to move on to the real ambiguous ones, where you can get one triangle or two triangles. All right, now we're going to come to the one where we get one or two triangles. And this is the true ambiguous case, because the other ones you could just stumble on. The error, I could have not told you much and just, there you go, you get an error, it doesn't work. The 90-degree one, obviously it's 90 degrees, the end. This is the one you got to be aware of. Now, again, maybe you don't notice it till you draw it, and that's the key too. That's why we want to draw a picture. So let me just draw one here. All right, so we're going to call this triangle 1, and then I'm going to draw over here what triangle 2 would look like. The best I can. Let me just kind of, this guy doesn't work perfect, but we'll do the best we can here. All right, I'm just going to put him over here. All right. So we could get one triangle, we could get two triangles, and let me show you what I mean. So let's just start setting it up like normal. Now you don't even know to draw that second triangle yet. So I got angle A is 45 degrees. Let's put corner B down here, and let's put C up here. All right, so side A, now I use 7 root 2, and you might be like, well, why'd you pick that? It's just so I don't have to write the decimal number for that, so it works out nice. So that's just a number, 7 times square root of 2, it's just a number. Side B is 7 units, and side C we have no clue. Now, we have no choice but to solve for angle B, but the thing we have to be noticing is we have an angle, side, side, triangle. That's the key. This is where we got to watch out. Now, same with the last ones. We had an angle, side, side, triangle, so we were careful. We were watching, except we got an error or we got a 90 degree, so there was nothing to worry about. Now, we're not going to get an error 90 degree here. So here we go. Let's check this out. So I start solving for angle B like normal, and I'm going to move a little bit quicker here because I know this is taking a long time. All right, so step 1. Let's find angle B. Okay, and I'm going to call it B1 here. Okay. Find angle B1. Now, we don't know that there's maybe going to be another triangle yet, but I'm going to call it B1 for now. Okay, so let's set that up. So we're going to go sine of B1 divided by 7 equals sine of A, which is 45 degrees, divided by 7 root 2. So obviously, you're going to multiply both sides by 7, take the sine inverse. So let me just set that up. Sine inverse of 7 times sine of 45 divided by 7 root 2. All right, and if you do that, you end up getting 30 degrees out. All right, so we didn't get an error, and we didn't get a 90-degree angle. So this angle here is 30 degrees. Now, if you have an angle side-side triangle, like we do, and if you don't get an error and you don't get 90 degrees, that's where you could have two cases. So what does the other case look like? It doesn't quite look like that, right? This is where B1 is. It's actually more like this. There's where B2 we'll call it would be. So here's A, it's still 45 degrees. Here's C, we have no idea what it is. Here's length C right here. Here's length B still right here, and here's length A right here. So the triangle is actually just this to this to this. That's the triangle, okay? All right, so how do we find angle B2? Well, from earlier in the note, it's always the same. To find angle B2, the angle in the other one, all you do is you take 180 and you minus B1 from it. Okay, so what's 180 minus 30 degrees? All right, we're going to get 150 degrees. Okay, so in this triangle, that corner would be 150 degrees. Now, let's find in both triangles angle C. So that would be up here in triangle 1. So we'll call this C1. Okay, so let's find C1. Okay, so I'm using 1 for triangle 1, 2 for triangle 2. And we'll call this guy over here C2. All right, so we did that. Let's find C1. How do we do that? Well, there's 180 degrees in a triangle. So angle C1 would equal 180 minus 45 minus 30. All right, so 180 degrees minus 45 minus 30 gives us 105 degrees. So this triangle works out just fine. There's nothing wrong with it, right? 45 plus 105 plus 30 makes 180 degrees, no problem. So let's go back to other ones. So there was step 1 over here. Let's do step 2 over here. Let's find, let me label this up here also. This is find angle B2. Okay. Now let's find angle C2. I've got the angle symbol over here. There we go. All right, so how do we do that? Well, we're going to do the same thing. Angle C2 is, there's 180 degrees in a triangle, minus the 45, minus the 150. And right off the bat, we should be realizing, oh wait, we got a problem. We're getting negative 15 degrees for C2 up here. Right here, right? This angle. Well, that's impossible. You can't have a negative angle, so that's impossible. All right, so that tells me right off the bat, there is no second triangle, okay? So there is no, there, right, is no second triangle because it's impossible. You can't have a negative angle, right? So there we go. So now this basically, long story short, this case just doesn't exist. We only have one possible triangle. Now we're going to do one more example after this where there is a second triangle. It starts out the same way, okay? So how would I know to check for that? Like I've been saying maybe too much repeatedly. Is it an angle side-side triangle? Yes. Did I get an error? Nope. Did I get a 90-degree angle? Nope. So that's how you know to check for the second triangle. Angle side-side, no error, no 90. Now, and then we basically assume that there's a second triangle, and we start finding its angle. And the first thing we do is, number 1, find angle B2, the other triangle's B, by subtracting from 180, and then find its C2. And if we get a negative for that C2, that means it doesn't exist. Now, if I don't get a negative for C2, that means the second triangle does exist. All right, so let's just go back and finish our first triangle. So what have we found so far? We found angle C is 105 degrees. We found angle B is 30 degrees. All right, all that's left to solve for is side C, and we can use the sine law to do that. So step 3, and I know I'm sorry I'm really squishing stuff in here. Let me do it up here at the top. Sorry for squishing everything. Side 3. All right, so how are we going to do that? Well, we have this angle. We're just looking for the side. So I'm going to start with side C divided by sine of 105, because that's the angle across from it, equals, now I'm going to use A again, right? Because I know that's 45. I know that's root 2. You could use the B. It's 30. You could use that too. We're very sure that that's 30 degrees. But if you're unsure, you're not 100% positive, you know, you can, yeah, we can use it. What the heck, right? We're sure we did it right. I'm pretty positive. All right, so here we go. Let's go 7 divided by sine of 30. I just don't want to use that angle if I had to round it, but since it's exactly 30, that's why I'm okay using it. If I had to round it, I'd rather use the 45 here and the A there, because I don't have to round any of that. I know those are exact numbers. Okay, so C equals 7 times sine of 105 divided by sine of 30 degrees. You punch that all in your calculator, and you are going to get, I think it's about 13.5 degrees, or 13.5. It might actually be exactly 13.5 units, okay? Okay, so we solved that triangle, and there was no second triangle. All right, let's look at the final scenario, which is the only difference that's going to happen, like I said, between this one and that one is right here. When I look for C in the other triangle, if I don't get a negative, it just means there's another triangle. And all I would do is to finish that triangle off is find its side C the same way I found this one's sine C. All right, so I know it's a lot. It seems like so much. Once you apply it, hopefully you realize it's really not very much. You're just looking for this one scenario, okay? All right, let's go to the last one. Okay, so here we go again. Now, when we start a question like this, like even when I started, I don't think much about what I have. I just draw a triangle like I did here, like I've done for every triangle. I just draw a regular old triangle and I go, okay, here's A, here's B, here's C, okay? Angle A is 43.1 degrees, okay? Side B across from angle B is 248.6. Sorry, it's a little sloppy. And side A is 186.2. Now, this is where the light bulb goes off in my head, right? From years of experience, and hopefully you from practicing this, right? I know I have an angle side side. Why is an angle side side one final time? Because the angle is not in between the two sides. It's an angle here and then a side side, okay? So that's the one I need to be aware of. Now, all I'm doing at this point so far, I'm not doing anything special. I'm just being aware that I might have the ambiguous case. Now, I might get an error. Then there's nothing. I might get 90 degrees. Okay. Or I might get the scenario where there could be one or two triangles. So all I do, like normal, is just start solving this triangle like usual. So step one. Okay, let's find angle B. Now I'm going to call this B1 again just because I know where this is going to go. Okay, so I'm going to call it B1. All right, so let's find angle B1. So how are we going to do that? Well, we're looking for the angle, so I'm going to start with that. Sine of B divided by the side across from it, 248.6, is equal to sine of A, 43.1, divided by 186.2. Now, just because I don't have a lot of room here, you'd multiply both sides by 248.6. You do the sine of 43.1 divided by 186.2, and then you take the sine inverse. So just for room's sake, I'm not going to write all the steps down. And you are going to get angle B1 is equal to 65.8, approximately, okay? All right, so that's what it is. This angle right here is 65.8 degrees. Now, we didn't get an error, we didn't get 90 degrees, and we are dealing with an angle side-side triangle. That is the scenario that we could have a second one. So I'm going to go over here and draw my second triangle that might exist. And the second triangle always looks like this. Basically, we're kind of ignoring all this part of it, right? It could look like that, okay? So, but the idea is, okay, well, here's where A is, which is still 43.1. Here's where C is. We have no idea. Now, in this triangle, this is what C would be. In this triangle, this is what C would be. Now, B1 is over here, right? That's that 65.8 degrees. But we want to know right here, where's angle B2? Right here. So it's the same every time, okay? Because this makes an isosceles triangle. So to find over here in our second triangle, oops, let's make that a 1. All right, let's find angle B2. And it's the same every time. All you have to do to find angle B2 is you're going to take 180 degrees, okay, and subtract angle B1 from it. Okay, so what's 180 minus 65.8? And we're going to get approximately 114.2. All right, so that's what this is right here. Okay, now, at this point, you're basically just solving two separate triangles. That's all you're doing. Draw two diagrams, set up two triangles, and just solve two different triangles. That's all you're doing here, okay? So let's go back to our first triangle for a minute. Let's find angle C, and we'll call it C1. So step 2, let's find angle. And you can solve them independently. You can just finish one and go do the other one, or you can just do them at the same time. I'm just doing it at the same time so we can compare what's happening here. All right, so it's a triangle. It has 3 corners in it. We know 2 of them. Let's find the third one. So angle C1 is 180 minus 248.6 minus 186.2. And you are going to get 71.1 approximately. All right, so that's what that is right there, 71.1 degrees. All right, let's go over to our other triangle. Now, in the last scenario, when we found angle C2, we got a negative number, which meant that angle couldn't exist and that triangle couldn't exist. In this case, we shouldn't get a negative. So let's call this angle C2 up here. All right, so C2 is equal to 180, 180 minus the other two angles, minus 43.1, minus 114.2. And if I do that right, I get 22.7 approximately. Now that's not a negative. 22, I'll just kind of squeeze it in here. I know it's super tiny. 22.7. Oh my goodness, that's a mess. That does not look like 22.7 at all. Let's try that one more time. 22.7. All right, that'll have to do. So this is not negative, right? So that tells you right off the bat, okay, this is fine. This works. It's not negative, right? So therefore, there is a second triangle. Okay? So that's it. So you just keep solving these two triangles like normal. So I'm just solving the first one like normal, solving the second one like normal, and finding the missing sides for each one. So now let's find this side. I'll label it in the first triangle. I'll call it little c2. I know it's hard to tell. And I'm just going to use the sine law to solve for it. So let me just do that up here. Here we go. Let's find side c2. All right, so I'm just going to go side c2 divided by sine of the angle across from it, which is 71.1. And I'm just going to use A here, 186.2 side A divided by sine of A, which is 43.1 degrees. All right, so we're going to multiply sine of 71, punch that in our calculator, times by 186.2, divided by 140 or by 43.1. And just to save time and space here, we should end up getting C1. Oh, I called that C2. Oh my goodness, I ruined it all. I called this C2. Everyone's confused. Why did you do that? All of this should be C1. Everybody's in the comment section screaming. Everything's burning down. This is C1. I am so sorry. Sorry guys, one take. Got to keep rolling. I got to record a lot of these videos. All right, C1, because we're talking about triangle 1, right? Triangle 1. Should have labeled them right off the bat. That's what I usually do, triangle 1. All right, C1, do all your calculations, and we should get 257.8. And there you go. That's the missing side there. I'll just label on my triangle here, 257.8. All right, let's go to the other triangle, which should be C2, and that's this length right here. Okay, we want to solve for that one. That's C2. So that's step 3 for this triangle, right? Let me just kind of cut these two apart. You hopefully can spread this out a little more on your page. I'm trying to squeeze this all into one little page here. All right, let's find side C2. All right, so to do that, C2 over sine of the angle across from it, and we just found earlier the angle was 22.7, and I'm just going to use A again like I used in the previous triangle, 186.2 divided by sine of 43.1. Okay, so you're going to multiply that by that and divide by sine of 43, punch it on your calculator, and if you do it right, I got 105.2 it looks like approximately, and there's that side right there. So that's that. I can't quite label that in there, so I'll just leave it be. All right, so we got 2 triangles. Now what you really want to do at the end of a question like this is list all your information. So I'm going to try and move down the page here and just kind of list everything off and kind of make a chart at the end, right? So angle A was given to us, but we still want to include that, 43.1. I'm going to write right next to it side A, which we already know is 186.2. All right, angle B is, what did we get, 65.8. And side B was given to us 248.6. Angle C we got is 71.1. I should put some approximates on these guys. Degrees. And side C, boy, I lost it. What is it? 257.8 units. So there's triangle 1, right? There's all its possible stuff. Okay, let's go over here and do triangle 2. Angle A is still 43.1 degrees. I forgot the degrees over here. Side A is still 186.2. All right. Angle B we solved for, and we got 114.2 degrees, and side B was given to us, so that's 248.6. And then finally, angle C. All right, angle C is, in this triangle, 22.7 degrees. And side C is, I've lost it now, 105.2 approximately. All right, and there's our 2 triangles. Now we can label these. It wouldn't be a bad idea to call these ones, 2, B2, C2. Oh, sorry, those are ones. I'm mixing them up again. Sorry, guys. B1, C1, C1, B2, C2, C2. There we go. All right, there's my 2 answers. So let me just kind of summarize here real quick what you're looking for, because at the end of this was a really long video and maybe your head's spinning, maybe you got to watch a couple times, do some textbook reading, but let me just kind of come down the page here and talk about this. All right, so there's really only one thing that's special you have to be always looking for when you are solving triangles. When you are given an angle like here and a side and another side. So when you're only given, here's the things, I'm only given one angle. That's the first clue. Only one angle. All right, so if I only have one angle, now there's only two scenarios. I'm either using the sine law, right, which is an angle side side, or I can't solve it with the sine law because I have a side angle side, so I have to use the cosine law. Okay, so we'll talk about cosine law later, and there's nothing special to that, so that's not the one we're worried about. So if I have an angle side side where the angle is not between the two sides, like this, okay, then I might have an ambiguous case. Now, you just start solving it like normal, and what can happen is either you get an error, which means there's no triangle, so nothing to worry about, right? 0 triangles. I'm just going to draw a triangle picture here. 0 triangles, okay? Or you get a 90-degree angle when you're solving for B down here, right? Corner B. So you get a 90-degree angle. So that just means it's a 90-degree, right? You have one right-angled triangle, one right triangle. So there's nothing special there. Or you get down and you don't get an error, you don't get a 90. So if you have an angle side-side triangle and you don't get an error and you don't get a 90, that's the one where you just assume there are two triangles. Okay, so this is the only scenario you need to be looking for. And again, it sounds like a lot, but it's not. It's just one thing. Assume there are two triangles, right? Because I don't even panic. Like if I get an error, it's an error. If I get a 90 degree, it's a 90 degree. So if I have an angle side side and I don't get an error, I don't get a 90, that's when I assume there are two, and I just start solving like there were two triangles. I set up two separate ones and I start solving them. So the one triangle looks like the one I drew here. The other one looks like this, right? Where we take that side here and we swing it over to here. Okay, so it ends up just looking like that. And we basically have B1 here, or we have B2 here. And then you have C1 here and C2 here. Okay, and you just solve it like two triangles normally. Now, you could have the scenario where one of the triangles you get an error. When you solve for B2, angle B2, it's a negative and you don't have a second triangle, right? So you'd only have one triangle. If angle B2, or sorry, that should be C2, but long story short, if you get a negative for C2, right, instead of B2, sorry, I'm starting to ramble. I'm getting tired of recording these videos all day. When you do C2, right, you get a negative. When you do, you get one triangle. If you do angle C2 and it's a positive, then there you go. You have two triangles and you just solve them both separately. So again, every time I write it, it seems like so much, but all I'm really looking for is angle side side. I assume there's two triangles. If there's no error, there's no 90. I assume there's two and I start solving. Okay, so give that a try. Check out the textbook. Read it through and really try these questions and really see if you can figure out if it's an angle side side and if there's two triangles on your own. All right, but don't be afraid to look at the answers, of course, too.